Yeah, so we wanted to spend a few minutes this morning to share with you some of the design and systems that we have collectively built at Twitter to enable the security, identity, and we'll talk about our AAA strategy for the project to move the Twitter's Hadoop infrastructure into GCP. So the aim of today is, if you were to go do a similar project, we should provide you with some inspiration. Hopefully, mostly what to do, or maybe a little bit of what not to do as well. But the idea is, if you were to do something similar, you would have a good starting point. So we're going to start off with a little bit of an overview of what is Partly Cloudy. I see a few folks with I see Derek in particular here with the Partly Cloudy shirt on. So it's a little bit about what is the project. We'll talk about the architecture that we've built and designed, and then some of the specifics about the project's identity and the much maligned Demigod services. So let's start. Vrushali, what is Partly Cloudy?
So Partly Cloudy is a project at Twitter to extend our data processing platform from an on-premises only model to a hybrid model, right? So we are not moving, or we are not setting it up such that you can run part of your job on premises and part of it in the cloud. It's more about running your job either on premises or also having the ability to run it in GCP. We started by deciding to move our ad hoc compute and our cold data storage to GCP. And this project is not just limited to the data platform team at Twitter, but a lot of teams at Twitter have been very closely involved with this. And not just Twitter, we've been working very closely with Google on this. We have an on-site Google presence at Twitter, and we collaborate very closely with Google for this project.
So with that in mind, why did we do Partly Cloudy, Vrushali?
So let's take a look at why we wanted to do this project, right? At Twitter, we've had a long-term desire to have some cloud presence, right? We wanted to be in the cloud, but then that meant arriving at a strategy that would balance our developer capabilities and agilities that come by being in the cloud with the associated cost and the effort that it takes to move to the cloud. Being in the cloud gives us a very convenient way to test changes at scale, right? It gives us a way to have business continuity, you have redundancy. And then being in GCP means we have access to so many of the Google offerings like BigQuery, CloudML, and anything new that Google comes up with. So hence Partly Cloudy.
Absolutely. And so as part of that, we kind of created a pretty strict brief at the beginning of the project, right? And specifically today, we wanted to talk about what we called the AAA strategy, the authentication, authorization, and audit capability. And these were three things that the Twitter team were very, very, very clear on from the very early days. These were things which we had to do when we actually rolled out this project into Google. And so in the next kind of 45 minutes or so, we'll talk you through each one of these and all of the design decisions and all of the complexity that came out of that and how we actually addressed that complexity. So on the authentication piece, we wanted to make sure that any time any human being or any kind of service account acting on behalf of a human being has access to data, that we can guarantee that it is the person who they say they are before they access that data. That we can guarantee that that person has the specific authorization to access that particular piece of data. As you might imagine, there's lots of data categories that we're dealing with here. So making sure that that person or that service account could only access that specific thing was very critical. And finally, after the event, we needed to be able to say, OK, who accessed what when? In the event of an incident, or even in the course of the day-to-day operations of the platform, just to be able to be certain that we had good visibility into what was actually happening. And so let's talk a little bit about the situation before we did Partly Cloudy. So, Vrushali, do you want to talk us through what it looks like on premises here?
Sure. So this is our architecture before we moved to Partly Cloudy. Here we have, this is a representative picture, right? So we've shown that we have more than one data centers on premises. All of the boxes are not drawn to scale, so don't interpret the sizes of the boxes as their sizes. Anytime you see more than one box, we want to say that we have more than one such cluster or more than one such instance. let's start from the left of the picture. The little blue birds that you see there, those are the Twitter users, who are interacting on Twitter. Maybe they're tweeting, retweeting, replying to somebody, having a conversation on Twitter. So all of these user actions generate data. Now, this data is collected by our log pipeline. That's the yellow rectangle in the picture. Yesterday, my colleague Lohit gave a talk about the whole data replication system at Twitter. So in case you missed it, be sure to catch it online. Now, this log pipeline writes the data to our real-time clusters. That is where the data is collected, aggregated, processed. And then from there on, it moves to the production clusters, the ad hoc clusters, and eventually ends up on cold storage. So this is our current architecture. This is our architecture before partly cloudy. Let's take a look at how it changes when we move to partly cloudy. Now, as you see in this picture, we have a third box. That is our Google Cloud setup. Our ad hoc clusters from on-premises have moved to GCP. Our data storage is now in GCS. And we have introduced a new cluster on-premises, that is the copy cluster. This copy cluster has the sole functionality of replicating the data from on-premises to GCS. We do not run general-purpose jobs on this cluster. The nodes on this cluster have connectivity to our internal systems as well as to GCS.
And what was it that, why choose to do the copy cluster? What was the goal there?
Right. So we wanted to restrict the blast radius of how many nodes on premises have external connectivity, because all of the GCP endpoints are public endpoints. We wanted to make sure that we have a few set of controlled hosts that have connectivity to the external systems. Now, this goes over a dedicated bandwidth connection. Right.
OK, so let's dig in a little bit then and see what that box on the right, what it looks like when we get into the Google Cloud piece. So I want to start off with the organization and project structure. Right, we'll start at the beginning. What we built out was we created a Twitter organization. And to be clear, the names in here are often they're placeholder names. They're not necessarily the real names. We have an org-level construct that is Twitter. Within that, we have a number of folders, one of which is the data infrastructure folder, which is the one where all this magic happens. And then within that, we have a number of different projects. There are a number of what we call pillar projects, which are specific to the particular areas of data processing in Twitter. And then we have a couple that are kind of service projects where we'll talk a little bit about some of those special cases as we move forward. So that's kind of the project level structure. What then do we have inside each of these projects? And this is where the kind of the new cloud native stuff really starts to happen. So inside each of those pillar projects, we have a number of pieces of infrastructure. First off, we have is what we call the nest node, the nest box, which is essentially a bastion or a gateway machine. So when users need to access this platform, this is the machine that they'll actually be connecting to. In addition, there are a number of name nodes. For those of you familiar with Hadoop, name nodes, resource manager, and worker nodes, very standard makeup of Hadoop here. The access to the buckets is where the access to the actual data is where it gets interesting. So the data, each one of the logs categories, which we'll talk about in a moment what each of those means, each of those logs categories is stored in a particular bucket. So here you'll see on the top right here the dataset bucket. That's where the actual logs data exists. In addition, we have the scratch bucket, which you can think of like a little bit like temporary storage, and a scrub bucket, where data which has had any PII, logs data that's had any PII scrubbed and removed can be stored. The worker nodes are the ones that directly access those buckets, with the exception of, in some cases, users can access some buckets directly, but that's on a very, very, very narrow use case-based process. The vast majority of the access comes from the tasks that are running inside the worker nodes who read that data out of the storage buckets. Now, later on, we'll talk a little bit about how we do the authentication around this, because that's, as you can likely see from here, now we've got a situation where you have jobs which potentially are running without the user there, right? There might be scheduled jobs, or there might be jobs which take long enough that a user wouldn't want to sit in front of the machine for 5 hours to run that process. And so you can see already where some complexity starts to come into this. So up until now, this has seemed fairly straightforward, and that was our impression when we started doing this as well. As we got into it, we found very quickly that some complexity comes in here. And so we tried to build in this process of minimum complexity. And every time we see something where we think, well, okay, hang on, look, that's getting maybe a little bit complex. Let's see if we can simplify and come back to something which doesn't involve so many moving parts. So what we've ended up with here, we're talking through now, it represents the bare minimum level of complexity to solve the problem in the way that we have.
So one thing I want to call out here is that we are running our own Hadoop clusters in GCP. The data, the input and output is in our GCS buckets, but all of the VMs are managed by us.
Yeah, absolutely. So each of these nodes that you see here, they are virtual machines in Google Compute Engine that's managed by the data infra team.
Yep.
All right, so what about the storage? Vrushali, do you want to talk us through that?
Sure. Yeah. So when we are replicating data from on-premises from our HDFS locations to GCS, we wanted to make sure we provide our users with the same unified experience. On-premises, when our users do data processing, and when I say users, I mean the data platform users, not the Twitter users. These are Twitter employee users. When they want to do data processing, they refer to an on-premises path, such as data center, cluster, user, and then the path. This is a logical path on-premises as well. This path gets mapped to an actual HDFS path by our ViewFS file system. On GCS, when we wanted our users to do data processing in GCP, we wanted them to have a very similar experience. So we have this logical cloud path, /GCS/user Helen. So the path remains the same. They only have to change the prefix to which, to indicate where they want to run their jobs and where their data resides, right? Now, this logical cloud path maps to an actual bucket path with the gs:// and you all might recognize the bucket name. The interesting thing here to note is that we have all of our buckets have prefixes and postfixes. Prefixes are words like user, logs, scrubbed. Those indicate the type of data that is in those buckets. All our buckets are dual region buckets, so that's the actual bucket type. But looking at a bucket name, we wanted to determine what kind of bucket this is. Is this a user bucket? Is this a logs bucket? Which is why we have a set of prefixes there. The postfix is dp.twitter.domain. Now, twitter.domain is a verified domain name that we got from Google. The reason is bucket names in GCS live in a global namespace. We wanted to make sure that our bucket names do not collide with other GCP users, other GCS customers, which is why we have a verified domain name.
Yeah, and that gives you the ability as well to quickly identify, like, hey, this is a Twitter bucket. Hey, this bucket is a logs bucket. And I think we wanted to do this for a couple of reasons, right? One was to maintain a similar user experience, right? Users are, and like you said, when we say users here, these are Twitter employees. This is kind of an internal service, right? When Twitter employees, their workflow, they're used to dealing with these kind of logical paths. So we wanted to continue that. Additionally, we wanted to create a situation where we could move buckets, rename buckets, right? Like we wanted to abstract the implementation details behind the scenes from the user interface. And that's kind of another guiding principle we've had through all this has been, let's make it seamless for the user. We haven't written that down, right? Because it's somewhat evident and it's somewhat true for every project that we do, right? User experience always comes first. And so to maintain a good user experience here, we didn't want to have the user sitting there and do a GS and a complicated bucket path, which could then change at some point in time. So we implemented this virtual mapping, which again, it added more complexity because now we have another layer where we have to map between the logical path and the real GCS bucket path. But again, there's complexity which was worth the trade-off because it increases that or maintains that user experience.
Yes. One thing that I can add there, like James said, we wanted to move buckets, rename buckets as we were working on this project because our design was evolving. And we put forward a request to Google for a tool or a utility that can move buckets across GCP projects or that can rename buckets. And Google has built this tool and open sourced it. It's on GitHub.
the
Bucket.
famous bucket mover tool.
Yes.
Yeah, we're laughing because it's been a fun project for us to do, and Google's professional services with their partners have written this project. If you want to check it out, search the Google Cloud GitHub organization. It is in there. Alrighty, so moving in then from data now to users. Let's take a little bit of a look about what it looks like from a user access perspective. Now we're starting to get into really into the details of this AAA strategy. So the first thing to know is, how did it used to work? So on premises, Twitter users are granted access to the existing HDFS and Hadoop infrastructure via their Unix username. With Kerberos authentication to actually access the Hadoop platform itself. Now, Kerberos and Unix users don't map all that well into Google's platform. You can't grant a Unix user access to a GCS bucket, for example. So we needed to find a way where we could do a similar thing in the cloud. What we ended up on, after many, many, many months and different iterations of how we should do this, we landed on this approach of using what we call a shadow account. So in this case, a shadow account is a Google service account which is nominally mapped to a human user account or an existing service account in the on-premises system, which we'll call a headless account.
Headless user, yep.
And so the way this works is that it's actually the shadow account which is granted access to the majority of the resources in the platform. And when the user needs to perform some kind of access, run a job, it's actually the service account that gets used. Again, though, we wanted to make sure that this was a seamless experience. The user doesn't actually necessarily know. Right?
It's completely transparent to the user, yes.
Exactly. We actually deliver the credentials required to authenticate to that service account to that user's Unix username and only to that user's Unix username. What that means is that the user, when they run a job, there's no login necessary. They log in when they access the system, right? But there's no additional step to generate the credentials for access in the cloud. That's all taken care of in the background. And in a few minutes, we'll tell you what the inevitable complexity of that is and how we solve that. But effectively, what we're saying is most of that access comes via this shadow account. Now, as I mentioned earlier, there are a few cases where a human user account may want to access some data in the platform, and so we do have in some cases the OAuth 2 access granted. That's most cases, that's for what we call the user bucket, which is the output bucket for jobs that users run, and where they're storing additional things which are kind of metadata and that kind of stuff in the platform as well. Yes. And then that maintains, Twitter is a G Suite user as well, and that maintains the access to the G Suite platform without changing it in any way, which was another thing that we needed to ensure happened here.
That way users can have other Google offerings that require G Suite access to buckets that would work there.
Exactly. Another piece that we haven't touched on but was a key requirement here is that there was a very, very, very firm decision very early on that we would not store users' G Suite credentials on these shared machines. Fundamentally, the nodes that you saw inside the project, they are shared resources. This is a multi-tenancy system. And we were very clear from very early on, we're not going to store the user's credentials there. The reasoning being the risk of leakage was too great. When you have multiple users all sharing a machine, it can become tricky to protect those credentials. Okay. Twitter already had a secrets system in place, which we were able to leverage in order to actually ensure some of that without having to reinvent the wheel. Speaking of keys, key management becomes a big part of this, right? Now we have a situation where the shadow account is the gateway to all of this information, so we better make sure that we have good security around that account. Authentication for a shadow account is performed using a JSON key. We generate a new key, and again, these are placeholders, right? We generate a key every n days. Then that key is valid for 2n plus n days. In other words, if we were to create a key which was valid, and I'm choosing numbers made up for the demonstration purposes here. If we were to say a key is valid for 10 days, or the period of n is 10 days, on day 1, the system would issue that first key. Right through to day 10, that same key would be issued. On day 11, we would issue a new key, and then that would continue to be issued until day 20. And then the same for 21 to 30, etc. Each key, however, can still be used for an additional 2 end periods after that, in this case 20 days. So in this example, each key would be valid for 30 days, but I would stop receiving it when I create a new job after 10 days. What that means is it gives the flexibility to still rotate keys quickly, but it also means that longer running jobs, which might last more than n days, can still execute in the background. As we mentioned, they're distributed by Twitter's existing security service, and it distributes the keys only to the machines that are going to need them. So the Nest machine, for example, would not have those keys on them. And the key is only readable by that user, and it's actually obfuscated from that user entirely. Did I miss anything on the keys? Good stuff.
Yes.
We got a little,
Very exciting. Yep.
Yeah, I mean, this is you're seeing here what is like what's that 6 bullet point distilling of something which took 8 months, I guess, to design and come up with an agreement on. And we went back and forth, and there's actually a few other competing things. A colleague of ours that we work with just released a white paper and a blog post on a token broker service, which we also considered for this. Like there are a number of different ways in which we could solve this problem. We ultimately decided on this one for the reasons that we've already discussed. So what that means is we now have a bunch of service accounts, right? Potentially thousands of service accounts. So what we wanted to do is let's separate those out and put them over in their own projects so that they're not affected by changes and whatever that we might make in those pillar projects. So we have a project specifically for the Twitter employee users, which just stores those service accounts. At some point in time, we may need more of those. I'm optimistic that the usage of the platform will continue to grow. And so at some point, we may need to branch out into additional ones, but at least for now, we have a single home for those service accounts. OK, so what do the users actually get from the platform, Vrushali?
So, well, we saw what we've created in GCP so far. What is it that the users themselves actually get? The users get a shadow account to access their data in GCS. Now, this is still transparent to the users. The users do not know, but then they have the capability to access GCS via their shadow account. They'll get a bucket for their data in GCS. They get access to a Hadoop cluster, to a Presto cluster. Basically, with the shadow account and the GCS setup, they can now run data processing jobs in GCP. Now, all of this is done by our system. For the users themselves, it's like a platform that has been set up for them to do their data processing jobs. And let's take a look at who configures this setup, right? Who does all of this for the users?
I think it's time for a little therapy session.
Yes.
So I'm very conscious that this is on camera and being recorded, so I'm going to say this for posterity. Unfortunately, I'm responsible for the name of these services. When we were having this discussion to begin with, it quickly became clear that we would need to have, at the time we were talking about one application which would manage all of this. And the concern from someone who I won't name but is in the room here was we don't want to have a godlike service. And that makes perfect sense, right? Because if you think about everything that we just described, there's a lot of complexity there, a lot of moving parts. So it does make sense to break it up into different things. And I unfortunately said, well, it would be a little bit like a demigod service then. And the name is stuck, so I apologize. It's not the best name in the world, but it's what we have and what we've been using for a while now. So what are the demigod services? Well, it is a set of services that are specifically written and built by Google and Twitter together to actually manage all of that complexity we just talked about, to rotate those keys, provision those buckets, manage those users. And they all run inside GCP. Do you want to talk to us a little bit about what some of the features of those demigods are?
So when we started thinking about these demigod services, we had a few key design considerations in mind. We wanted them to run asynchronously of each other. We wanted them to run independently of each other. We wanted them to run with exactly scoped privileged accounts. So like James mentioned, we wanted these services to have admin privileges, but not a huge blast of admin privileges, a very restricted scope of admin privileges granted to each demigod service. We wanted their runs to be idempotent, so even if they run again and again, they reset the system state to what is expected. the demigod runs will override any manual changes, and that was something that we wanted. So because we have so many thousands of buckets, thousands of user accounts to manage, and we wanted to make sure that whatever setting exists in GCP is what we expect it to be. We wanted the demigods the code itself to be modular in design so that we can maintain each service independently of each other. We know exactly what each service is doing, and we wanted it to be as simple as possible. Right, that's the key.
Yeah, there's a diagram coming up where you can see the level of simplicity we managed to achieve. It's not what it could be, but it is a good compromise. And so I wanted to come back to the idempotent piece again for a second, because I think this is incredibly important for this process, because all these services, they are controlling access to what can be fairly sensitive data, right? And so we wanted to make sure that it's a very predictable, repeatable, and reliable process. If we had a situation where 2 different runs of the tool could end up with 2 different outputs, we would be in a really bad place, because it would be almost impossible to maintain, it would be impossible to troubleshoot. So we really wanted to make it very declarative, and in a moment you'll see most of the inputs that we give to these tools, they are of a declarative nature. It's LDAP or it's YAML that actually specifically codifies what the tool is going to do, and the tools will do the same thing with the same input every time. Okay, so let's talk about the actual demigods. We're going to talk about 4 demigod services today. Let's start off with bucket creation. Vrushali, what does the bucket creation demigod do?
Like the name says, it creates buckets. It's responsible for the overall bucket management as well. This demigod, we wanted it to run 1 per pillar project. So if we have a demigod service for one of our GCP projects, that bucket creation demigod has the ability to create buckets only in that particular GCP project. So it's restricted access scope. Almost all of our demigods have configurable inputs that they can take. All of our demigods look at an LDAP input. This LDAP input tells them information about the bucket ownership, where to create the bucket, and there's a YAML input as well that gives it additional information about the different configuration options for that particular bucket.
We also have the shadow account management demigod service. So this is the service that's responsible for provisioning and deprovisioning the shadow accounts that we discussed. So it notices when a user has been granted access to the platform and will create that service account, that shadow account, and provide it with the correct IAM roles on the basis of the group's membership, which we'll talk about in a moment. Again, inputs, LDAP, and YAML. And again, in this case, there is one of these across all of the pillar projects. The reason being, we have one service account provisioning project. So it doesn't really make sense to have individual ones of these, because it's managing something that's a single point for everything. We also have bucket creation, which is what we just talked about. Yep. We also have policy management. If you want to talk us through that one?
Sure. So this particular set of services is responsible for setting the IAM policies on all of our buckets. This, again, runs 1 per pillar project so that it has its access scope to that project. This demigod service interacts with Google Groups as well. It manages, because it needs to give access to a bucket, and that is scoped to a Google group. So the IAM policies are set for a Google group for a particular bucket. We also made sure we added an ignore list option. I want to call this out. So in case, let's say you're debugging a problem, there's some situation that you want to take care of, and you don't want the demigods to come and override some settings that you've done while you were debugging things or while you were taking care of things. So we have an ignore list that you can pass in that tells the demigod service, oh, do not reset the bucket permissions for this particular bucket.
Exactly. And then finally, that we want to talk about today, we have the key lifecycle management service. So we abstracted this away from the service, the shadow account creation service, and instead run it as its own service. Again, this actually executes what we talked about earlier of the key rotation. It creates keys, it expires those keys, and rotates those keys. The other thing that it does, though, which we didn't really touch on earlier, is it actually pushes those keys into the secrets system that Twitter has. So it will actually, once it's generated that key, it will grab that key and then push it into the key store. And again, its input again is the destination for the key, so it needs to know an endpoint to push to. And again, it will read from the LDAP, and it will notice that recognizes when those shadow accounts exist. So we wanted to talk a little bit about how we actually put these things into practice and what some of that deployment looked like. And I promised you a diagram which demonstrates the level of simplicity that we achieved. Well, here it is. As simple as possible, but this is a complicated thing that we're doing here. So do you want to talk us through the complexity here, Vrushali?
Yes. So we have not shown all of our demigod services or all of our projects or it's not a comprehensive diagram, but it's a representative diagram. We would have run out of space and arrows otherwise. So all our demigods run in an admin project. So this is a separate GCP project. We have our other data platform processing projects like the Twitter Infra product project and the user project. The demigod services run in this project, but are scoped to work on the target projects. So we have separate instances, like shown here, bucket creation for the IE one, bucket creation for the product project. We have the policy granting demigod. Starting from the left in the picture, you'll see some LDAP groups and Google group interactions. The demigods are basically set up to look at LDAP groups as one of their inputs. They interact very closely with Google groups. We use the Google Groups API, and we add users or shadow accounts to Google Groups. We set IAM policies on our buckets using Google Groups. So we use Google Groups extensively. Our configuration input goes into a bucket itself. So the demigod services, whenever they start up, they look at this config bucket. And for every run, they can, if the config changes, that's, their run will change. We have a key store, a secret store that Twitter manages. This is a Twitter key distribution service, and that is responsible for moving the keys to whatever nodes it needs to be at. The destinations can be set, and this is our own system. This is a similar thing that we have on premises as well, so our users are used to that interface. Let's take a look at some of the deployment considerations that we had. All of the demigod services run in GCP itself. They run on VMs. The VMs themselves run with a service account. Now, this service account is again created in the admin project itself. And that service account is scoped to what it needs to have, the privileges that it needs to have. The project itself has limited SSH access, so only admins can access it. The reason we've separated it into a separate project is we wanted to have a clear delineation of what resources we are using for our admin work. What is it that we need to set up? We can control our access to that particular project accordingly. The processes on those VMs run as Kerberized headless users. One important consideration that we had for the key creation service is that it should not write the keys to disk. We do not want to be leaking keys at any point. So the demigod service holds it in memory and then writes it to the secret store.
Yeah, and I think we've kind of mentioned this a couple of times, but it's worth calling out one of the key parts of this design, and the reason we were able to do this effectively was that we had this secret management system already. All of this depends upon there being a way to reliably and securely distribute those keys where they need to be. So we were fortunate when we began this project that Twitter already had one built and rolled out. Had that not been the case, we might have needed to use something like Vault or some other method of distributing those keys. And we looked into doing that as well at the beginning, and that comes with a different set of challenges. So for those of you who were thinking about doing something similar, that is a key part that we haven't really touched on too much today that needs to get solved, how you actually distribute those keys. Okay, should we look a little bit about what happens when these things actually run? So we built them, we've designed them, we told you why we have them, we've designed them, we've built them, and now we're going to actually run them and see what it looks like. So what happens when a user joins an LDAP pillar group? So the first thing that happens is a shadow account is created for them. So the LDAP pillar groups, they are indicators to the system that this particular human being has become a part of the team that needs access to this service, or has been for some reason granted access to the service. Once that happens, the shadow account creation service will notice and will provision that shadow account for the user. It will also create a GCS user bucket for that particular user. It will then, and that will be the bucket creation service. The key service will then generate a key for that user and add it to the secrets system. And then that secret system will distribute the keys accordingly to the right places in the infrastructure. So each one of those things is separate from one another. They don't really, I mean, they do somewhat depend on each other, but it doesn't have to happen in order like this. It will just be the next time that service runs that it will pick up from the changes. Each one is, think of it like a flow. One happens after the other, but it doesn't matter if it's exactly sequential. What about when a new data set is added, Vrushali? What does that look like?
So our dataset storage on GCS is based on a dataset ownership model, like we saw. So how do we ensure that new datasets that get added are actually getting their buckets in GCS? So this is an event-driven system. Whenever we have a dataset information that gets added on premises, that information gets replicated to a YAML file in a config bucket. Now, this config bucket is actually one of the inputs to the bucket creation demigod. So once the demigod sees that there's a new input there, it looks up the ownership in LDAP, does the corresponding ownerships and settings in Google Groups, and creates a bucket. It also creates a corresponding set of scratch, scrubbed buckets that we require for our processing. The IAM policy demigod will then grant privileges. These ownership or these read-write settings are, again, a configuration input to the demigod service. So the demigod service is more like a rules engine. It takes a set of inputs, and then it has a set of actions that it does. Once the input changes, it notices that, and it performs the corresponding action.
Yeah, so the idea here is, with the exception of I as an owner, well, it's not me, Vrushali, as an owner or administrator of the data infra platform, has one step to add a user. We add them to that group, and there's some governance around that as well. But it's basically one manual component, then everything else triggers out and flows automatically from there. And so all those demigod services are all operating in the background, go into creating this system so that the user can very quickly and very seamlessly access it. And we've actually rolled this out. It's there today, and most importantly, it works.
Yes.
It works. We actually have users using this platform with the demigods running, with them automating access. And what we found is, like, it's still fairly early days, but what we found so far is we found a couple of bugs and wrinkles that we have to work out. But all in all, so far, we've seen it to be working pretty effectively, which is it's pretty good, right? We've been working on this for a couple of years. It's good to have it finally rolled out. And so what we've seen is that now those users, and we're actually seeing people come to the team and ask for access, right?
Yes. And it's, like I said, it's the same experience that people have on premises. You know, they join LDAP groups, they make changes to their config files, those get checked into our source repository. So it's the same experience, it's just that things, again, happen on GCP.
Exactly. It's the user doesn't know that it's in the cloud, but it is in the cloud. All right, well, with that, both of us are hiring. Quick chance to take a plug. If you're interested, come see us afterwards or visit these websites. And with that, we have about 10 minutes left. Does anybody have any questions?